Yeah. I wind up with a lot of kids from him just because they want one-on-one and I do one-on-one. All right, guys, geo. Let's do geo. All right. Don't worry if you hate geometry or you weren't good at geometry. It's okay. I'm going to make it as easy on you as possible. There's a lot of things you learned in geometry, like proofs. Remember proofs that'll like put you in the fetal position in the corner? You don't have to do those, so don't worry about it. There's also a lot of things that were really complicated in geometry class that you don't need to know. So again, we'll make this as simple as we can. All right. Quick few notes on your general approach. So general approach for geometry problems. Pictures are wonderful things in geometry problems, guys, okay? Geometry problems are visual. So if you're not given a diagram, draw one, okay? Make sure you label your diagrams. Whether they're your diagrams or their diagrams, label them. Anything that's given in the problem, write it down. Write down your formulas you're going to need. And then estimate if you can't solve it. Remember that those figures are drawn to scale, okay, unless otherwise noted. So if you need to estimate something, if you're given a lovely looking rectangle and you're told this is 10 and you're told to find that, well, you know it's less than 10. It's probably around 5, somewhere between 4 and 6, okay? So use that to help you solve the problem. If your figures are not drawn to scale, then everything's out the window and that x could have been 25. So fun times. All right, basic vocab. Let's talk some basic vocabulary here. Perimeter. Perimeter is just the distance around a figure. You are not given any formulas for a perimeter, but you don't need one, okay? Perimeter is just adding up the sides. Look at the lengths of the sides, add them up. If you've ever heard the phrase, walking the perimeter, what does that mean? To walk around the property. So you're walking around a shape, just add up the sides. Circumference. The circumference is just a fancy word for the perimeter of a circle. The formula for the circumference is on your formula sheet for your SAT. Remember, you have to know it for your ACT because you're not given a formula sheet. Circumference formula is 2 pi r or pi times your diameter, whichever one floats your boat. Area. The area is just the space inside of a figure. There are a bunch of different formulas for areas. Again, see your formula packet for the ones that you need to know. Okay. All right, geo review. Let's get into some meat. We're going to start with lines. Okay, so linear relationship is y equals mx plus b. This is the slope-intercept form of a line. I would hope most of you have seen that 800 times at this point in your life, in your math career. So m is your slope, b is your y-intercept. Y-intercept means that's where it crosses the y-axis, okay? Your slope can be found from 2 points using this equation right here. This equation is not on your formula sheet. You do need to know it, y2 minus y1 over x2 minus x1. That's how you get the slope from 2 points. A little bit about slope. Parallel lines. Parallel lines have the same slope. Parallel lines are your lines that look kind of like that. Okay? They look the same, they have the same slope. Perpendicular lines. Perpendicular lines are your lines that intersect at a right angle. There we go. Okay? So perpendicular lines have slopes that are negative reciprocals. What does that mean? That means that if the slope of one line is 3/4, the slope of the other line, the line that's perpendicular to it, would be negative 4/3. Change your sign and flip it over. Okay, so 3/4 and negative 4/3 would be an example. 1/2 and negative 2 would be another example. Questions on that before I move on? Definitely going to come up somewhere. Okay. All right. Couple other helpful formulas, also not on your formula sheet, your distance formula. You do need to know this. x2 minus x1 squared plus y2 minus y1 squared. This is the distance between 2 points. Midpoint formula, using x1, y1, and x2, y2. This is how to find the midpoint between 2 points on the coordinate plane. It's an average, guys. Like, that's all you're doing. You're taking the average of the x's and the average of the y's. So add your x's together, divide by 2. Add your y's together, divide by 2. This formula is very useful if you know both ends and you need the middle. Okay? If you have the middle and one end, this formula is very cumbersome and a pain in the butt. So we're going to look at an example problem where we have the middle and an end, and I'll show you an easy way to get the other end. All right. ACT number 3 is yours to do for homework. It's just finding the slope from 2 points. So just apply your slope formula. Let's look at ACT number 2 for a minute because people do have trouble with this one. What is the slope of the line based on the equation law? So if I want to get the slope out of an equation, I need it in y equals mx plus b form. That way I can pluck that m, that slope, right out of there. So I'm going to solve this for y. So first thing to do to solve that for y, I'm going to subtract 5x from both sides. So if I do that, I'm going to have negative y equals 2x plus 6. Again, all I did was subtract the 5x. Okay? But I don't want negative y, I want positive y. So I'm going to multiply both sides by a negative. So I'm going to get y equals negative 2x minus 6. So now I'm in y equals mx plus b form. And I can just grab my m. So my m is negative 2. So my slope is negative 2. Okay. All right, number 4 right below it is yours to do for homework. It's finding distance. So just apply your distance formula. SAT number 3 at the bottom, we'll do real quick. In the xy plane, which of the following ordered pairs is a point on the line y equals 2x minus 6? Now, a lot of people think this has to be really complicated, but you have numbers in your answers. What do you do with numbers in your answers? Plug them in. Yeah. Your first number is x, your second number is y. So I'm going to start randomly. I'm going to start with 7, 7. I'm going to start with b. So I got 7 for y equals 2 times 7 minus 6. So 7 equals 14 minus 6. That's 7 equals 8. That doesn't work. Fail. I'm going to try C. 8 equals 2 times 7 minus 6. Ooh, parentheses in wrong spot. Did I? Oh, fun times. Because I updated your packet and I didn't update the PDF. Hold on. I thought I took that question out. I'm like, why is this question here? Hold on a second. Because that question is more than 2 years old, and I don't use stuff that's more than 2 years old. So I was like, why is this guy here? Let's fix this. No big deal. We can fix this. Can't see what I'm doing. There we go. All right, this should be your packet. There we go. Like I said, I thought I took that question out. I was like, why is that there? Okay, better. That should be the question at the bottom of your page, right? All right, cool. Thank you for pointing that out. All right. Okay, so this was the midpoint question I was telling you about where you have an end in a middle and you need the other end. So this is the one where your formula is not helpful to you. So let's look at how we fix that. So point B is 4, 3 is the midpoint of the line segment AC. If A has coordinates of 0, 1, then what are the coordinates of point C? All right. So let's draw ourselves a little picture of what's going on here. Point B, 4, 3 is the midpoint. So I'm going to put B in the middle since it's the midpoint. A has 0, 1, so I'm going to put A on an end. It doesn't really matter where I put it, if I put it on the left or the right. But A comes before B, so I want to put it on the left because that's the way my brain works. And I'm looking for C. All right, this can be solved just with some basic common sense here, guys. All right, so let's just look at our x coordinates. How'd you go from 0 to 4? You just went up 4, right? That's it. Okay, so you added 4. Now that's halfway. B is halfway. So if that's halfway, to get to the other end, I just got to do that again. So 4 plus 4 gives me 8. So my x coordinate of point C should be 8. Make it a sense? Yeah, okay. All right, we're going to do the same thing for the y coordinate. For the y coordinate, you went from 1 to 3, so that's up 2. Again, that's halfway. So to get to the other end, add another 2. 3 and 2 is 5. So the coordinates of point C are 8, 5. Okay. Ma'am?
How did you know that the formula wasn't going to work and that you had to do this instead?
If,
there wasn't a picture? Or?
no, if you're only given an end in the middle, do it this way. If you're given both ends, use the formula.
Okay, thank you.
No problem. And the formula will work. It's just going to be cumbersome and gross, and it's going to involve a lot of algebra. So this is just easier. Okay, any questions on this? Okay. All right, this next one is a real common ACT problem that pops up. Oh, all right, so, well, hang on, let's read through the problem first and I'll explain it. Students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance d feet. The cart was from a reference point at 1 second intervals from 0 to 5. Which of the following equations represents the relationship between d and t? Now we can notice that these are all linear, and we can absolutely come up with a mx plus b equation out of this table. We can totally do that. However, that would only work for this problem. What if your equations were quadratics? What if they had squares in them? What if they had cubes in them? What if they had ln's in them? What if they had e's in them? Okay? Let's look at a method that's always going to work no matter what your equations are. Okay? We like one method for everything. Cookie cutters are good. So that method is just going to involve something very simple, and that is taking your data out of your table, plugging it into your answers, and seeing which equations work. So let's start with 0 and 15, because plugging in 0 is easy. So I'm going to plug in 0 for t and 15 for d and see which equations work and which ones I can rule out. I'm going to start with the first one. So if I plug in 0 for t, do I get 15 for d? Let's see. So is 15 equal to 0 plus 15? Yeah, that works. Keep A. B. Is 15 equal to 3 times 0 plus 12? Well, 3 times 0 plus 12 is 12, not 15. B fails. C. Is 15 equal to 3 times 0 plus 15? Well, that's going to be 0 plus 15. That's 15. So 15 is equal to 15. Yeah, C works. Keep C. D. Is 15 equal to 15 times 0 plus 3? 15 times 0 plus 3 is going to be 0. 0 is not equal to 15. No, try that again. 15 times 0 plus 3 is going to be 3, not 0. 3 is not equal to 15. Get rid of D. And then E, 15 equals 33 times 0. 0 is definitely not equal to 15. Okay, so just with your first data point, you're down to a 50-50 shot. Okay. All right. So since we still have 2 answers, let's go to our next point, 1 and 18. So now we're plugging in 1 for t, and we're going to see if it gives us 18. So I only have to check A and C. So A, I've got 18. Is that equal to 1 plus 15? Well, 1 plus 15 is 16. That's not 18. A is out. C, just to double check, 18 equals 3 times 1 plus 15. 3 plus 15 is indeed 18. C works for both data points, so C is my answer. Okay. Any questions on that method? Again, that will work no matter what equations you have down there in your answers. Okay. We like one method for all types of problems. Thank you. All right. 53. Which of the following values is the x-coordinate of the point in the standard xy coordinate plane where the graph of the line y equals 7 intersects the graph of the function y equals the natural log of x minus 2 plus 3? Now, first of all, don't freak out when you see a natural log. As far as y'all are concerned, it's a button on your calculator. Okay. Here's the important part. We're talking about an intersection here. Anytime 2 equations intersect, That means that their x values and their y values are equal at that point. How does that help us? It means this y right here is equal to that y right there. So you can substitute it in. So that means y, or 7, is going to be equal to this messy equation. So 7 equals the natural log of x minus 2 plus 3. And that's the equation I have to solve. Okay? Which is gross, but hang on. Not as bad as it looks. So this ln of x minus 2, that's the thing that has my variable in it, right? So this is the mess that has my letter in it. I want to get that mess by itself. So the first thing I can do is get rid of that 3. Let's move that 3. I'm going to subtract 3 from both sides and make this 4. 4 equals that mess. 4 equals ln of x minus 2. Okay? At this point, I have numbers in my answers. Okay, they're ugly numbers, but they're numbers. I could just plug those boogers in and see which one gives me 4. Okay? I know if I was you, I would start with 6 because it's easiest. So if I plug in 6, 4 equals ln of 6 minus 2, which is 4 equals ln of 4. That's a 4. Okay, again, on your calculator, as long as you have a scientific calculator, you will have an ln button. Okay, so you just have to find it. If you have a scientific calculator, you probably have to do 4 and then ln. If you have a graphing calculator, you're going to do ln and then 4. Anybody have trouble finding the ln button? We'll be happy to show you where it is. If you have a TI, it's about the third or fourth one up from the bottom on the left-hand side. Okay. But if you type this in, this is not going to work. Just FYI, that's going to go. Okay. Again, these are all numbers. They're gross numbers, but they're just numbers. So let's work our way down. Let's try B. E to the fourth plus 2. E. E is an irrational number. It's kind of like, you know how pi is an irrational number? It's 3.141579, blah, 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 blah stuff. E is like that. It's 2.71, blah, 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 blah stuff. Okay? E, again, it's just a button on your calculator. Most of the time, it's going to share a button with ln. So if you can find ln, E is usually second ln, or vice versa. Okay? So e to the fourth, you do second ln, put in the 4, and then plus 2. And that's going to give you some ugly, disgusting decimal. Maybe around 56-ish, probably. Yeah. Blah, 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 blah stuff. Okay? So, take this ugly, gross number, put it in here, and see if it works. Is 4 equal to ln of 56.59 stuff minus 2? And see if this gross thing gives you 4, or something really close to it. If you get like 3.99999 or 4.0001, you're close enough. You're fine. Okay, and that should work. This should give you something really close to 4.
So I understand what you did. I just don't understand like how you do that.
How I knew to do which part of it? Yeah.
Like I just don't understand how you went from like y equals 7 and other things.
Oh, gotcha. Okay, I gotcha. So anytime you have two things that intersect, that means that you can set the x's and the y's equal. So since y is 7 here, the y here would also be 7. Okay, so that's how I set this up. Okay there? Okay. Then this mess contains my letter, and I want to get any mess with my letter alone. So I move the 3. And then I'm at this point where I can plug in. Because I'm looking for the x-coordinate, and I don't want to have to solve this. If you know how to solve this, by all means go for it. But most people don't know how to solve natural log equations. Yeah. Does that make more sense now? Yeah, okay. The other thing to remember about this problem is this is a 53, right? Your ACT tends to save everything between 50 and 60 for the harder problems, okay? So the fact that this is a 53 means it is in that like hard section. Okay. Are we okay, semi-okay with this? All right. I know it's kind of a rough one. All right, let's move on. All right, new topic, number 4. Which of the following could be the equation of the line represented to the right, which has absolutely no numbers on your graph whatsoever, because that's what your SAT likes to do to you. When you're faced with a graph with no numbers, we have to apply a little common sense. The best place to start is that y-intercept. So let's start with that y-intercept. It's up there. Is it going to be positive or negative? It's going to be positive, right? Okay, so whatever your y-intercept is, it's a positive value. So that means our b is going to be positive. So if we go over to our answers over here, our b's are going to be positive. I can get rid of b and c because those guys right here are negative. So I can mix them. So it's either a or d. So now the difference between a and d is my slope. Is your slope of this line positive or negative? Are we going uphill or downhill as we go from left to right? We're going downhill, right? Easy way to tell is if you drew a car on the left-hand side, that car is going downhill. If you're going downhill, it's a negative slope. So negative slope, D. That's how we do that. Okay, number 12 there, that's yours to do for homework. You get numbers on your graphs. Number 8 on the next page with the big graphs, that's yours to do for homework as well. Again, you get numbers. Makes it easier when you actually have numbers on your graphs. Okay. We're going to do 22. Because this is an all sorts of special problem. Okay, the graph of the function f is shown in the xy plane to the right. The function f is defined by the equation that for positive constants a, b, and c, where a over b is a fraction of lowest terms. Which of the following orders a, b, and c from least to greatest? Okay. So they gave us f of x equals a over b times x plus c, which should look a lot like y equals mx plus b. Okay, so it's just another way to write mx plus b and kind of mess with your brain. So let's figure out what's what. Your c is in the place of your b, which is your y-intercept. Okay? So let's go find our y-intercept. Our y-intercept is where it crosses the y-axis, which is kind of hard to see on here, but easier to see on your paper. It crosses the y-intercept at 2. So, right there, that's your c. So your c is 2, one letter down. A over b is your slope. So we just need to calculate out the slope. We have a graph. We can just do rise over run. Count up, count over. Okay? They even gave us 2 points. Cool. So if I count up, I got 1, 2 going up. Count over, 1, 2, 3, 4, 5, 6. So I got 2 over 6 for my slope. Reduce, that's 1 over 3. There's my a over my b. So a is 1 and b is 3. Okay? And then we just got to put it in order from least. Yes, ma'am.
I kind of forgot how to do when we were doing the counting. What do you do after you count those?
Just put the up and down over the left and right.
Okay, thank you.
Yep, and if you go up, it's positive. If you go down, it's negative. If you go right, it's positive. If you go left, it's negative.
All right, thank you.
Yep, no problem. I actually get that question a lot. Because it's like, oh God, Algebra 1, I haven't done that in how many years? And we just got to do it in order from least to greatest, so that's going to be ACB. So ACB is that guy. All right. Oh, stay. Okay. Shortcuts. So a lot of times the test makers like to give you things in what we call standard form. Standard form is absolutely freaking useless. It's this ax plus by equals c. So it's like 2x plus 3y equals 4. It's useless. You can't get anything out of it. You can't get your slope. You can't get your intercept. You can get nothing. Okay? Until now. We always used to have to transform that into y equals mx plus b. We don't have to do that anymore. Here's shortcuts. Okay? So if they give you something in standard form, your slope is negative a over b. Your y-intercept is c over b. So let's look a little closer at that. If I want the y, I'm going to take the thing on the other side, and I'm dividing it by the thing stuck to my y. That's how I get my y-intercept. Okay, the thing on the other side divided by the thing stuck to my y. If I want my x-intercept, same idea. Thing on the other side divided by the thing stuck to my x. That's going to give me my x-intercept. Okay, I don't have to keep transforming this equation over and over in order to get those anymore, which is really helpful when all of your answers are in standard form. This is a huge time saver on this test. All right, so let's look at how we use this. The graph of which of the following equations is parallel to the line with the equation that? All right, so I want parallel. Parallel means same slope. So the slope of this line is right there. It's -3. So that's my goal. I'm shooting for -3. Okay. All of my answers are in standard form. I don't want to have to transform each and every one of those into mx plus b. That's annoying. So I'm going to use my shortcut. M equals -a over b. Okay. This dude. So -a over b. My a is a ninja 1. So I have -1 over -3. That's 1/3. That is not -3. So a is out. B. Again, I have a ninja 1 here. So m is -a over b. So -1 over b, which is -1/3. So I have -1 divided by -1/3. I don't even have to do this division to know this is not my answer. Negative divided by negative is a positive. I'm shooting for -3. Not my answer. C. Again, -a over b, -1 over 1/6. Okay, I got a fraction within a fraction. This is a keep, change, flip situation. Keep the -1, change to multiplication, flip the bottom over. That's -6. Not helpful. Process elimination, my answer better be D. Okay. Questions on that? All right, cool. The one after that, number 19, is yours to do for homework. Again, use those shortcuts. And we're going to do 15. What is the distance between your x-intercept and your y-intercept of this glorious line? Well, in order to find the distance between them, we better find them. So let's locate our x-intercept and our y-intercept. So our x-intercept, again, is the thing on the other side divided by the thing stuck to my x. So -18 over 2, that's -9. Okay, my y-intercept, thing on the other side, -18 divided by thing stuck to my y, -3. That's 6. Now, if I want the distance between these guys, I need to use my distance formula, but that involves coordinate points. So I need to rewrite these guys as coordinate points. So an x-intercept of -9 means that my x is -9 and my y is 0. Y-intercept of 6 means that my x is 0 and my y is 6, because it's 6 on the y-axis. This is -9 on the x-axis. Okay. So now that I have two coordinate points, I can do my distance formula. Root x2 minus x1 squared, y2 minus y1 squared, and plug. Okay, so label your points x1, y1, x2, y2. You can do it in reverse if you want. Doesn't matter. Just be consistent. x2, I've got that labeled as 0, so we're going to do 0 minus -9, whole thing squared. y2, 6, minus 0 squared. So 0 minus -9 is 9. 9 squared is 81. 6 squared is 36. 81 plus 36 better be 117. Let's see. Any questions on that? The one that I gave you for homework, you're going to have to use the shortcut to get. You won't have the distance formula, but you'll have the shortcut. And there's a previous problem that involves the distance formula. So you get practice on both of them individually, just not together. Okay. All right, 12 and 13 go together. All right, so I'll give you a minute. Go ahead and read through this whole mess up here. Because you're actually going to need that for 13, not for 12. Okay, so which of the following is closest to the equation of line of best fit? So we're looking for the equation of the line. And again, we're going to start with that y-intercept. Okay. One thing to watch out for with this y-intercept is make sure that it corresponds to x equals 0. Make sure you have a 0 down here on your x-axis. There will be problems on some of your SATs where this is not 0. If this is not 0, then that is not your y-intercept. Okay. So be aware of that. Watch out for it. In our case, this is 0, so that is our y-intercept. It's 54. It's positive 54. Which answer has positive 54 as your y-intercept? That's it. You're done. We don't care about the rest of it. We don't care about slope. Ma'am. So if it doesn't start at 0, then we would actually rule out C. Our y-intercept could not be 54. Okay? And usually what will happen is if this is not 0, there'll be two answers that have a y-intercept of 54, so you'll actually usually be able to rule out 2. And you'll have the other two answers that have a y-intercept of something else, but it'll be the same thing. So you know it's one of the other two, and then you go to your slope, figure out your slope. Make sense? Okay. All right, we got that. Let's go to number 13. Number 13 is not a math question. Number 13 is a reading question. Which of the following is the best interpretation of the slope of the line of best fit? So if we're talking about the line of best fit, are we talking about actual data, or are we talking about a prediction or a model? Talking about a prediction or a model, okay? Your SAT will always use the words prediction or model when they're talking about line of best fit. You're always looking for one of those two words. So if we go down into our answers, we can get rid of the two that say actual. So get rid of A and get rid of C. You know it's either B or D. Now it's just a matching game. So we have the predicted increase in the percentage of households or the predicted increase in the number of households. If you look at your graph on your y-axis, you have percentage of households. So it's B. Okay? Don't overthink these. Again, always look for the words prediction or model if they're talking about line of best fit, and then literally just match it up to what's in your graph. Number 27 is actually yours to do for homework, and we're going to do 24, which is right after it. 27 and 24 are very similar. We're just going to do the harder one. Okay. In the xy plane, line L has a slope of 2. If line K is perpendicular to L, which of the following could be an equation of K? All right, so we have two lines. We have line L and we have line K. So start by kind of separating out your information here. Line L has a slope of 2. And what we know about line K is that it's perpendicular to L. So if it's perpendicular to L, what's its slope? Not -2, you're close. -1/2, there you go, don't forget to flip it over. The negative reciprocal, negative and flip it. Okay, so we know the slope that we're shooting for is -1/2, that's our goal. So if we're shooting for -1/2, let's go to our equations. And again, apply that shortcut, m equals -a over b. Okay, so if I do that with a, -a over b is going to be a -10 over -5. That's a lot of negatives. So negative is positive. So positive 10 over 5 is going to be -2, not -1/2. So that fails. B, -a over b would be -3 over -6. That's positive 1/2, not -1/2. C, -a over b, -4 over -2. That's positive 2. And D, I got -6 over 12. That's -1/2. So that'll do the trick. Okay. That's how we do that. All right, let's take a break and then we'll do lines and angles.